GMAT all day.
Sequences and consecutive sets, like most things on the GMAT, are strongly related to divisibility. I could probably include a divisibility example for pretty much every single video series in this course, including the geometry videos. I could probably even include one in verbal. I've seen some critical reasoning questions that are almost like quant questions, talking about factors and stuff like that, but you don't want to hear about that here. So let's do a divisibility problem related to sequences and consecutive sets. If m is the sum of all the even multiples of 3 between 115 and 365, what is the greatest common factor between m and 300? And so before I can get to this part here, talking about greatest common factors, let's first just find m. Because to do that, we just need to know our properties of consecutive sets from the previous video. So first, let's find our actual range here, because so is 115 a multiple of 3? Sort of seems like it is because it has a 15, but to be a multiple of 3, the digits must sum to a multiple of 3. These sum to 7, so it's not. So is 116 a multiple of 3? No, so 117 is the first multiple of 3 here, which looks sort of weird for some reason. What about 365? Shouldn't be a multiple of 3 because it ends in a 5. 364? No, so 363 should be the last one. But we only care, though, about even multiples of 3. And so one thing we can do is we can write out all the multiples of 3 and just cancel all the odd ones. But if you did that, you'd probably see that even multiples of 3 really just means multiples of 6, because 120 is a multiple of 6, and then we're just going up by 6 every single time. And that should make sense, because if something is even, that means it is a multiple of 2. And so if something is a multiple of 2 and a multiple of 3, it's going to be a multiple of 6. And so our actual range here is the 117 is not even. So our first number is 120. Then 363 is not even either, so 360. So we can sort of rewrite the question as, if m is the sum of all the multiples of 6 between 120 and 360, what is the greatest common factor between m and 300? And so now let's just find m using our properties from consecutive sets. 354, 360. M should be equal to the mean, so mean should be the first plus the last over 2. So 360 plus 120, 480 over 2, times the number of terms in our set. So 120 should be our 20th multiple of 6. 360 should be the 60th multiple of 6. So number of terms, last minus first plus 1, 60 minus 20 plus 1, 41. So m should be equal to 240 times 41. Now, so I can multiply this out if I wanted to. Do I want to? Probably not, because they're not asking us to solve for m. They're asking us to find the greatest common factor between m and 300. So if I want to find all the factors of m, I want to be breaking this guy down, if anything, not making it bigger. So let's talk about, so first we're comparing two numbers. So let's find all the factors for each of our guys. To find all the factors for any number, usually best thing to do is break it up into its prime factors, because then you can make all of the factors from prime factors. So 300 will contain a, so 100 times 3, 25 times 4, 300 is 2 2s, a 3, and 2 5s. So what about m? M is this guy here. So 41 is prime. We don't need to break that up anymore. So what about 240? So 24 times 10. times 5. 3 2s. We can really write m is equal to 4 2s total, 2 to the 4th, 3 times 5. And then don't forget about the 41 here. So 4 2s, 3, 5, 41 is our m. So we are trying to find the greatest common factor between these two numbers. If you watch the divisibility series, you might recall that to find the least common multiple between any two numbers, you can break those numbers down into their prime factors, and then you need to find the least common multiple, you need to extract each of the prime factors that they share, and the number of times that you count each of them. You got to take into consideration the number of times where it appears the most. And so I think of least common multiple, you got to count each prime factor, the number of times it appears the most. Least goes with most. In this case, we're looking for the greatest common factor. Find the greatest common factor, I think greatest goes with the least. We need to find all the prime factors they share and then count each of them, the number of times they appear the least. So the greatest common factor between m and 300, let's start with our 2. So I have 4 2s over here. I have 2 2s over here. So we need to count out the number of times it appears the least. We only need 2 2s. For our 3, it appears once here and once here. So just count it once. Our 5, we have 1 5 here, 2 5s here. So just count it once if we want to. 41, it appears 1 time here and 0 times here. So we don't count it at all. This here should be our greatest common factor. This is a trick for finding the greatest common factor between any two numbers. So it should just be 4 times 15, which is 60. So we never even fully calculated what m is. We could find the greatest common factor, 60d. No, divisibility is the common thread that unites every subject. On to the next series.